Hi, I'm Kamal Takodra. I'm a technical marketing engineer in the HP Aruba switching business unit, and today I'm very pleased and excited to bring you an overview of some of our 10.14 CX switching release features. So let's get into it. AOS-CX 10.14 release introduces bum replication using pin bidirectional for underlay multicast. For a single EVPN-VXLAN fabric with IPv4 underlay. Overlay can use IPv4 and IPv6 and L2 and L3 VNIs, and the bum traffic is confined to the L2 VNIs here. Standalone VSF and VSX architecture is supported for access VTEPs. The traffic type for this feature is bum, so broadcast, unknown unicast and multicast traffic. Using pin bidirectional in the underlay, the Aruba CX switches themselves become both sources and receivers to build a stark homology multicast tree. No feature pack is required for this enhancement. Now let's step back a bit and quickly have a look at Ingress replication. For example, with Ingress replication here on the left, we send a bum packet. As shown, the source IP, which equates to the source VTEP, needs to resolve the destination IP, and thus destination VTEP VNI for each possible endpoint an inner bum packet is sent, as shown. This increases the burden on the Ingress VTEP and link bandwidth consumption. The spines do the forwarding as per normal. Now let's look at underlay replication. We turn on underlay replication with pin bidirectional in the underlay. The same source VTEP now receives a bum packet as shown. Again, the source IP, which equates to the source VTEP, needs to resolve destination IP. However, this time we use a multicast group IP in the underlay to send the inner bum packet once to the spine. The spine then forwards to all interested parties of the multicast group. This reduces the burden on the source VTEP and reduces bandwidth, and spines do the forwarding as per normal. The use case here is to move from head-end replication to multicast replication of bum traffic. This provides efficiencies in EVPN-VXLAN architecture with less burden on the Ingress VTEP, with more deterministic control of bum traffic. The supported platforms which can do bum multicast replication for EVPN-VXLAN are the 6300, 6400, 8100 and 8360 as access and leaf switches. The 6400, 8100 and 8360 can also be spine aggregation and core, but will only be transits and not performing replication. Also the 8325, 9300 and 10000 platforms in the single fabric can be transits only platforms, i.e. non-VTEPs. Now let's go across to a short demo. In this topology, we're going to review EVPN-VXLAN ingress replication versus underlay replication. In this topology, we have three VTEPs. VTEP 1 at 192.168.1.20 on the CX6300, and VTEP 2 192.168.1.159 on the CX6300, and then finally VTEP 3 at 192.168.1.160 on the VSX pair. Each VTEP has a layer 2 VNI, VNI 180 on VTEP 1, VTEP 2 and VTEP 3, and we'll be using VNI 180 throughout this demonstration. VTEP 1 will be the source VTEP in all cases. 4 broadcast frames will be sent from a host generator on VTEP 1. We will then compare Ingress versus Underlay replication in 2 scenarios. Let's kick off with head-end Ingress replication. And now let's start packet trace on the VTEP. And from our host generator on VTEP 1, we're going to send 4 broadcast frames. Now back to the packet trace. The 4 broadcast frames generated 8 frames at the source VTEP for stretched VNIs. That's 4 frames times 2 VTEPs, which equals 8. So the replication is proportional to the number of VTEPs across the stretched VNI. Taking a closer look at the first frame, we see source VTEP 1, 1.20 sending to VTEP 2 at 1.1.59. Further examination of the frame shows that this is VNI 180 and it's a broadcast destination, all Fs. Looking at the second frame, we can see source VTEP 1 at 1.20, this time going to VTEP 3, 1.160. The second frame sending to VTEP 3 is also related to VNI 180 and broadcast destination, all Fs. This cycle is repeated per broadcast frame. Source VTEP frame replication increases with the number of VTEPs in a stretched VNI. Now we're going to change to underlay replication. With PIM bidirectional operational, we now add underlay replication to all VTEPs using the replication mode command. Aruba CX auto maps all VNIs to specific multicast addresses. In this case, our interest is VNI 180, which is mapped to 239.1.0.180 for our quick tests. Let's start off with the packet capture again. Now let's send the 4 broadcast frames from the host on VTEP 1. Now back to the packet capture. Only 4 frames are sent by the source VTEP 1. We now have a 1-to-1 mapping of broadcast frames. On closer examination, we see source VTEP 1, 1.20 is now sending a frame to 239.1.0.180 for VNI 180. Further examination shows that this packet is indeed VNI 180 and broadcast destinations, all Fs. The second broadcast frame from source VTEP 1, 1.20 also sends a frame to 239.1.0.180 for VNI 180. Again, the packet detail shows VNI 180 and broadcast destination, all Fs for this packet too. The cycle is repeated per broadcast frame. Frame replication is only sent once per source VTEP per VNI stretch. This method reduces the processing requirement on source VTEPs and helps reduce the burden on the source VTEP in these situations. I hope that is useful and informative to you, and thank you for watching.